Alright, ladies and gentlemen, this is going to be the next video on cellular respiration. And specifically, we're going to be looking at calories. Let's get started on this next video. So how much energy is in food? Well, a lot, and your body requires food to create this energy. Now, if we look at this, we're going to measure that energy in calories. And calorie is simply the amount of energy needed to raise the temperature of 1 gram of water 1 degree Celsius. And the FDA is going to recommend that there are 2,000 calories per day. Now, let's look at some typical foods. We have 105 calories in a banana. And if I were to go through and consume 19 bananas, well, I would have a 2,000 calorie intake of those 19 bananas over that 1 day period. Now let's say I take this hamburger. This hamburger has 677 calories. So what are we going through and measuring here? Well, the 677 calories is simply going through and saying that it has more energy. Compared to my bananas, I would get my 2,000 calories eating 3 burgers over the course of a day as compared to eating my 19 bananas, which are 105 calories each. Now, if I go through and eat a big thing of French fries, well, a big thing of French fries is 510 calories. And if I consume 4 of those boxes of fries, well, now I'm getting 2,000 calories worth of my caloric intake in those 4 boxes of fries. So when we're looking at calories, it's how much energy food contains, so that way we can go through and look at the differences between food and the amount of chemical energy that they have. Food and the amount of chemical energy that they have. So how do we release the energy from food? Well, we're going to use our mitochondria, and then we're going to use the 4 macromolecules from all the foods that we eat. So remember, these are the fats, the proteins, the nucleic acids, and the carbohydrates. Now, if we were to compare 1 gram of sugar, well, sugar is glucose, and it's going to release in 1 gram 3,811 calories. Now, if I compare that to, let's say, 1 gram of triglycerides, that's fats, things that we're going to find in our butters and our lards, that's going to release 8,893 calories. So we can see the foods that we eat have different amounts of calories, and different quantities are going to yield different parts and different amounts of chemical energy. So let's go through and take a look at calories here. Now, we can do basic calorie calculations kind of using these estimations. 1 gram of protein is going to contain about 4 calories, and 1 gram of carbohydrates is going to also contain about 4 calories. Now, if we look at fats, well, fats are going to contain about 9 calories per gram. So if we compare bacon and turkey, we can do the calculation. We can see different quantities of masses and different quantities of energy that we're going to yield between the turkey and the bacon. All right, so let's do a little bit of a comparison between bacon. So bacon here, and then we also have turkey. Now we're going to assume for these basic calculations that carbs have approximately 4 calories. And then we'll go through and assume that our proteins, they are also going to have approximately 4 calories. Now, lastly, we're going to look at fats. And we're going to assume that fats, or triglycerides, have 9 calories. So 9 calories per fat here, or per gram of fat. So if we're looking at this, we have carbs, proteins, fats. And what we're trying to go through is compare the composition of bacon and turkey. Now here's the thing, we have to understand this is a really basic calculation here. This is a very simplistic way of me going through and doing this, but it will still give us a general idea of how to compare our bacon here versus our turkey. So let's take a look at our bacon. We got 2 slices of bacon here, and we have, so write down bacon. It has, for proteins here, we have 5 grams. We're going to multiply that by 4 calories for proteins because, in this case, there's about 4 calories per gram of protein. Now in the bacon there are no carbohydrates, but there are 6 grams of fat. So we're going to multiply 6 multiplied by 9 calories per gram of fat, and we're going to get a grand total of approximately 74 calories made up by those 2 strips of bacon. Remember, we have 2 slices or 2 strips of bacon here. Now, if we look at our skinless roasted turkey, well, let's take a look at this. We have 11 grams, so I'll write down turkey here, so that way we know we're looking at our 3 slices of turkey. We have 11 grams of proteins, and those are 4 calories per gram there. We have 3 grams of carbs, so we're going to add 3 grams of carbs here. We'll multiply that by, again, about 4 calories per carb. And then we're also going to have to add in our fats. Turkey only has 1 gram per fat, and there are 9 calories per gram of fat here. So if we look at this one here, we're going to get a numerical value of 65 calories. So 65 calories versus 74 calories. Now 3 slices of turkey, skinless roasted turkey versus our 2 slices of bacon. So skinless roasted turkey and 2 slices of bacon. Well, they have a pretty significant calorie difference here. Even though their grams are relatively the same, we actually can see that the bacon has less grams than the total grams protein, carbs, and fat in our turkey. We can see it has significantly more calories, and that's mainly attributed to the high quantity of fat in the bacon. Because the fats have 9 calories per gram, it's going to go through and contain much more energy in a smaller package here. So we can look at bacon versus turkey. Well, which one is going to be better for us to eat? Well, it depends on what our caloric intake is, and it depends how many fats we want in our diet. If we were just consuming bacon for the whole day, well, that probably wouldn't be good. And if we wanted to reduce the amount of calories, but eat a similar quantity of food, well, we could go through and eat this skinless roasted turkey. So let's go through, and what we're going to look at is how many calories that I need per day in order to maintain my current body weight. All right, so let's go through and look at my caloric intake and how many calories I need to go through and maintain my body mass here. So if we look at this, I am 25 years of age, I am a male, and I am also 5 foot 11 inches. Now we're going to do my weight in pounds. So if we look at this, I am 173 pounds. I am going to maintain my current 173 pound body weight, and I would consider myself moderately active. I usually get about 3 days a week worth of exercise, and my job I would generally consider sedentary. I'm not doing any physical labor. So therefore, this is what I'm going to put down here. Now, if I calculate this, what it tells me here is I need 2,329 calories in order to maintain my current weight. Now, what you can do with this is you can see if I want to gain more muscle, I would have to go through and I can calculate this here. I'm going to need to consume 2,829 calories if I want to go through and put on more muscle mass, and I would have to eat foods in higher proteins. So what we can see from this calculator is exactly how many calories that we're going to need based on our mass, so our actual weight that we have, and then dependent upon our lifestyles, dependent upon the energy that we go through and do throughout the day. Now, if you were to play sports and you were to consider yourself a very active person, and let's say I go through and calculate that for myself, well, I have to consume more calories because I'm trying to consume more food to get more energy. And if I was extra active, I would have to consume 3,000 calories a day. So if you've been paying attention in my video, this doesn't seem to make sense. I said that 1 gram of sugar and that 1 gram of fat had something like 3,000 and 8,000 calories. Remember, a calorie is the amount of energy needed to raise a temperature for 1 gram of water 1 degree Celsius. So really what it is it's a measure of chemical energy. Remember, chemical energy is stored in the bonds, and we're breaking apart those bonds to release that chemical energy. Now here's the thing, if we look on our nutrition facts, let's say on the back of this label here, what we see is this has 230 calories and 40 calories from fat. Well, here's the thing, this is really kilocalories, and the equivalent calorie calculation for this is actually 230,000 calories. Now the FDA does not use kilocalories because it's a little bit harder to say and a little bit harder for people to grasp. We use calorie and kilocalorie kind of synonymously. So when you look on the nutrition facts, what you're actually seeing is the calculation for kilocalories. And if we go back to our example here, that 3,811 calories, well, that's technically kilocalories. We call them calories for short. And that 8,893 calories, well, again, that is technically kilocalories. And we're measuring it in kilocalories, but we use the word calories because it's easier for people to understand. So what is weight loss then? Well, technically, weight loss is the loss of mass. It's the loss of fat in your body. It can also be the loss in proteins. But what our body's doing is we're going through, and let's say we consume less food. Well, when we consume less food and we take in less chemical energy, we're going to have to go to our stores, our energy stores in our body, and that's the fats. We will burn those fats to go through and create energy via the ATP. So we'll take the energy from our triglycerides and we'll turn it into ATP. So my caloric intake should be 2,329 calories per day. If I consume more calories, if I eat more food and consume more than that 2,329, my body's going to store it as fats or potentially proteins dependent upon what I eat. If I go through and consume less, well, I'm going to lose mass, and that's what burning fat is, and that's what exercise is. So by exercising, I need to consume more calories to fill in that void. And if I don't eat the calories that are necessary to maintain my body mass index, well, I'm going to burn fat, lose mass, and therefore I'm going to go through and lose weight in my body. So our body's going through and we're creating this process called cellular respiration. And this is where organisms obtain energy from the food and the presence of oxygen. And we're breaking the bonds in the food consumed to turn it into ATP. Now, the organelle that this happens in is the mitochondria. And the mitochondria is going to go through this chemical formula here. The chemical formula is we're going to take in oxygen and glucose, so 6CO2 plus C6H12O6, which is produced from photosynthesis, and the process of cellular respiration occurs. We get 6CO2, 6H2O, and then we get our ATP energy. So if we were to represent this in words, well, in words it's going to be like this. Oxygen plus glucose is going to yield, so our reactants are oxygen and glucose, our products, carbon dioxide plus water plus energy. So, did you guys learn? Well, did you learn a couple of things? Did you guys learn what a calorie is? Did you guys learn the basic calorie calculations? And then did you guys go through and learn about the fundamental formula for cellular respiration, how this process occurs? This is going to be the end of the video, but I will see you guys in class tomorrow.